Hello all. Our next topic is replication, and this topic you can refer from book that is Distributed Systems by Coloris. So replication is nothing but creating multiple copies of same resource and storing it in different location, or having more than one server providing same set of services. That is, replication can be for the resources or it can be for the servers that provides the services. Now, why do we need to do replication of resources is for the two main reason. One is for fault tolerance, the other one is for increased availability. Now, what happens is that if we store a resource or a data only in one location, then if any kind of failure occurs, and because of which the data gets lost, the user will not be able to get their data. So to solve the problem of failure in distributed system, the same resource will be stored in more than one location. In that case, if some of the location fails having the data, user's request will still be satisfied from the other locations. So that is to deal with the failure condition which may arise in the distributed system, the resource will be stored in the same copy of the resource will be stored in more than one location. So that is for fault tolerance. Another use for replication is to increase the availability. So let us say if the resource is stored in same location, then all the requests to use the resource will be directed to the same location because resource is present only in one location. Now in that case, if the number of requests gets increased, then there will be bottleneck near the location where the resource is stored. It is communication bottleneck because large volume of requests to the same location will not be served by the computer network efficiently, because of which the remaining request that comes to the location will get dropped by the network, because the network will not be able to handle that many requests to that location, or it will not be able to deliver that many requests to that location, as a result of which some requests may get lost in the network, as well as this particular location wherein the resource is present may not be able to serve all the requests, as a result of which, because the resource is present only in one location, the performance with which user will be expecting to use that resource may not be achieved. Now if the same resource is stored in multiple locations, let us say if I have a distributed system as this one and a duplicate copy of same resource is present in many different locations, then what can be done is the user's request can be distributed to different locations, like what Google server does. Okay, they store the data in different location, and whenever we request to use any data, our request will be directed to the nearest location where the data is present. So all the requests of the user in the distributed system may be distributed to different location so that it can be served easily and in a faster rate. So that is to increase the availability of the resource in the distributed system, we do the replication of the resource. Another replication in distributed system that is done is for the replication of servers. That is, we usually have many servers providing same set of services. Now why do we need to have many servers providing same set of services is again for performance enhancement, because if there is only one server that provides the services to all the client, in that case all the user or the client request will be directed to that server, and the server may not be able to process all the requests and provide the services efficiently. Similarly, if that server fails, then also the user's request may not be satisfied. So reason for replication of the servers are also same. That is, for the fault tolerance, if one server fails, the user's request can still be served by the other server, and for performance enhancement of the services. That is, if we have multiple server providing same set of services, then client's request can be distributed to those multiple servers, and the overall performance that user will be getting will be better. Now in this chapter, basically what we will be discussing is how the replication is performed to deal with the fault tolerance problem. Now in the first chapter, we had seen that there are two types of failure that can occur. One is fail stop failure, the other one is Byzantine or arbitrary failure of the processes or the servers. Now if it is fail stop failure of a process, it means the process will not be able to provide the services because the process will be failed, has been failed completely. Now if it is arbitrary or Byzantine failure, it means that the process is working but it is producing wrong result. So it is not working as what is expected from that process. So if we want to deal with fail stop failure, then if we want our system to tolerate f number of failures, then we need at least f plus 1 number of process or the services. That is, if f number of server fails, user can still be getting the services from that last one remaining server. Now how this arbitrary and Byzantine failure is dealt in the distributed system is using the concept of voting. So if the system is going to suffer from arbitrary or Byzantine failure, okay, that has to be determined by the administrator during the design and development of distributed system itself. Now if we want our system to tolerate, let us say, f number of arbitrary or Byzantine failure, in that case, based on voting, which we had discussed in the first chapter, that we need to have minimum of 2f plus 1 number of servers. That is, let us say, if we want one server failure, then we need to have 3 replicated servers. If we want 2 server failure, then we need to have 5 replicated servers. Now with this one, so in this chapter, in this topic, basically what we are going to see is how the replication of servers or the services is being done in distributed system so as to deal with the fault tolerance problem. So whenever we do replication in the distributed system, it can be the replication of resources or object or the data, or it can be the replication of servers in the distributed system. There are 2 properties which can be checked. Any one of the 2 property needs to be satisfied by the replication process that we are doing in the distributed system to deal with the fault tolerance problem. One is called as linearizability. The second one is called as sequential consistency. So this linearizability is more strict in comparison to sequential consistency. Now what linearizability says is that the replicated shared object service is said to be linearizable if for any execution there is some interleaving of series of operation issued by all the client that satisfies the following 2 criteria. So the criteria is the interleaved sequence of operation meet the specification of single correct copy of object, and the second one is the order of operation in the interleaving is consistent with the real time at which the operation occurred in the actual execution. So let us say we are doing the replication of the object or the servers, and let us say there are various clients who are requesting for that replicated copy. Let us say those are C1 and C2. Now C1 is executing, let us say, 3 operations O11, O12 and O13, and C2 is going to execute 3 operations, let us say O21, O22 and O23. Now when this request will go to the servers, they will be executed in interleaved manner. That is, it is not like all the operations of C1 will be executed first and then all the operations of C2, because the distributed system should deal with the problem of concurrency. That is, even if there are many clients who are currently using the same resource or the server, they should not be getting this feeling that there is some interference from other client. So their operations will be executed in the interleaved manner. Let us say the server is executing operation 11 first, then operation 21, then operation 22, then it can be operation 12, operation 23 or operation 13. Okay. So here what is happening is the different operations from different client is getting executed in the interleaved manner. Now this is how when multiple client request for the object or the resource or the services from the servers, the various operations will be executed. Now the linearizability property requires 2 things to be satisfied. The first is, even if the operations are getting executed in the interleaved manner, they should be meeting the specification of single copy of that object. That means even if various operations from different client are getting executed in the interleaved manner, so if we see the set of operations with respect to each client, they should be executed in the same order which that client had requested for. For example, client is requesting for operation 11, then operation 12 and then operation 13. So in this order. Now if we see here also, now in this one also, if we see, the operation 11 is getting executed first, and then operation 12 is getting executed, and then operation 13. Similarly, if we see the other side, that is client 2 wants operation 21, had requested for operation 21, then 22, then 23, and in the distributed system where the replication is happening, there also operation 21 is getting executed, operation 22 is getting executed, and operation 13 is getting executed. So they are satisfying the requirement of specification of single copy of the objects. Now second requirement of linearizability is the order in which this operation will be executed, or the interleaved operation will be executed, should match with the real time at which operation was occurred. That means in the real time, at what time client 1 wanted operation 11 to be executed. Similarly, at what time client 2 wanted operation 23 to be executed. So it has to be executed in the same time as was requested by the client. So because the timing also has to be satisfied by the servers here, so linearizability property is very strict. Now we will see another property which is called sequential consistency. Sequential consistency also requires 2 things to be satisfied. The first is interleaved sequence of specific operations, okay, should satisfy the specification of single copy of object. Another one is order of operation of interleaving should be consistent with program order. This is what is the difference. So similar to that of linearizability, in case of sequential consistency also, the client will be requesting for set of operation, and what are those set of operations that the client had requested for. Those set of operations should be executed in the servers. Okay, so all the operation has to be executed in the server side, similar to that of linearizability. Now the second criteria is not very strict in case of sequential consistency. It only says that the order in which the various interleaved operations will be executed, it should only satisfy the requirement of program order. That means in which order client had requested for, satisfying only that order will be sufficient. That is, here if we take the previous example, then the order in which the client had requested for was C1 had requested 011, 012 and 013, and C2 has requested for 021, 022 and 023. So in this order only the respective client want their operations to be executed. So similarly in the distributed system also the same order has to be followed. So that is, only the program order has to be maintained, whereas in case of linearizability it says that it has to match with the real time at which the operation was occurred in the actual execution, whereas in case of sequential consistency only that order of operation has to match with the order in which the client had requested for. So one of these two property has to be satisfied by the replication service that we execute in the distributed system. Now to deal with the fault tolerance problem, there are two ways of doing the replication. One is called primary, also called as primary backup replication. The second one is passive, also called as primary backup replication. The second one is active replication. So we are going to see what is this passive replication for dealing with fault tolerance in the distributed system, and what is this active replication to deal with the fault tolerance problem of the distributed system. So in case of passive or primary backup replication, the servers or the location wherein the replicated data will be stored, they will be divided into two categories. So one will be the primary, remaining will be the backup. So duplicated servers are called replica manager here. That is, different server providing same services or different servers storing the same or the same copy of the data. Now let us say we have these are the replica managers. So that means they are either providing same services or they are either storing same set of data. Now one will be acting as a primary replica manager and remaining will be acting as a backup replica manager. Now how this primary backup replication works is, client will have front end, a service to interact with the servers. Now from the front end the request will be provided to the primary replica manager. So all the client request will go to primary replica manager. It will execute the request of the client and provide the services to the respective client. Now if that request is to update any data or make change in any data, then primary replica manager will also communicate this information to all the backup replica manager, wherein they will be updating their data. So if it is only to get the data, read the data, or client is only requesting for some service from the primary replica manager, then from there only primary replica manager will be providing the services or the response to all the client. But if the request is to change some data value okay, make some modification in the data, then after sending the reply back to all the client, the primary replica manager will also be updating or sending the updation request to all the backup replica managers. Now this passive or primary backup replication has 5 steps. One is called as request, coordination, execution, agreement, and finally the response. So request means the front end, that is the interface that is going to interact with the replica manager. In the request phase, these are the various steps or the phases in passive replication. So in the request phase, the front end will be sending the request to the primary replica manager. So that is going to have a unique identifier so that primary replica manager identify each request uniquely. Now after that is the coordination phase, wherein primary replica manager will be taking each request one after another in the order in which it will be receiving from the client, because it needs to satisfy either linearizability or the sequential consistency. Then it will check that unique identifier for each request. Now if the request is already executed, it may so happen because distributed system is built on top of computer network. Okay, so the failure of communication can also happen, like the same request can be delivered more than once. So that is what primary replica manager is going to check for. And if based on the unique identifier, if the request is already executed, okay, simply the previous response will be sent. Otherwise, it will go to the execution phase, wherein primary will be executing the request and it will be storing the response, because if it gets the same request again, it is not that client will be requesting, but because of the computer network, the same request can be delivered again more than once. Now, so in this execution phase, primary will be executing the request and then it will be storing the response in the memory. Now the next phase is agreement phase, wherein if the client is requesting for update, then primary will be sending that update information to all the backup replica manager, and it will also be sending that unique identifier so that backup can identify that is what updation is to be performed. Then backup will be sending acknowledgement to the primary replica manager. And the last phase is response, wherein primary will be sending the update or the response back to the front end. So these are the various phases of primary backup or passive replication for dealing with the fault tolerance problem. Now the second type of replication is called active replication for dealing with the fault tolerance. Here what happens is that in case of primary backup replication, at a time only one server was working and remaining were only sent the update information. So if there is any change in the data, then other backup replica manager were working. And if any point in time, if that primary fails, one of the backup server will be taking the responsibility of primary replica manager, and this is how the fault tolerance was happening. In case of active replication, all the replica manager will be working in parallel. So every client request will be forwarded to all the replica manager. They will be executing parallelly. They will be producing the result, and the result will be sent back to the client via front end. Now this front end will be doing the voting of all the result which it will be getting from different replica manager. So based on the voting, the highest vote will be considered as the correct answer, and that is what will be sent back to the client. So this is the active replication. Now which replication we want to do, we want to go for, that is passive or active, it depends on what type of failure we want to deal with, okay, or what type of failure the replication manager is going to suffer from. Is it going to suffer from fail list of failure, or it is going to suffer from arbitrary or the Byzantine failure? So in case of active replication, all the replica manager will be executing their part of request. That means here the request will be multicasted to all the replica manager. So this is, I am writing multicasting here. So all the requests will be multicasted to the various replica manager. They will be executing their part of request, producing the response, and response will be sent to the front end, which will do voting, and based on the voting, the highest vote will be considered as the correct result, and that will be sent back to the client. Now this active replication also has 5 phases. The first one is request. So front end will be using unique identifier, and it will be sending request. That request will be multicasted to all the replica manager. Now the ordering has to be satisfied, as I'm saying, that is either linearizability or sequential consistency has to be satisfied. So we need a reliable multicast communication. So that is in the request phase. In the coordination phase, all the replica manager will have to make sure that the client requests are executed in the same program order, okay, at least. So that means in which order the client had requested for the different operation, it has to be executed at least in the same order. Next one is execution. So every replica manager will be executing the request. It will be producing the result based on that. The next one is agreement phase, which is not required here, which was required in primary backup, because if there is any update, then the primary had to communicate this with all the backup replica manager. Here all are working parallelly. If there is update also, all are updating their data parallelly. So agreement phase is not required. Now in the response, as I said, all the replica manager will be sending their result back to the front end, which will do the voting, and then the client will be getting the final correct result. So this is about the replication technique for dealing with fault tolerance in the distributed system. Thank you.